All right. Okay. Right. Thank you, everyone. We're super excited to do our demo day two. The first one was really super helpful, and we got a lot of feedback, and several people have given very good feedback, and they found it helpful. So we are here to do the second one. So the small change in the second one, we unfortunately Akshat could not do it live, so we just recorded the demo for the first part, and then I'll be doing the question and answers live. So without further ado, let's just go with the demo. Interesting topic, my favorite, eBPF, and how we at Levo are leveraging eBPF and its magic to do API discovery and documentation at an unprecedented scale. We're super excited about it. Let's dive in. Okay, so this is the agenda. Overall, in the demo day, we will give a very brief explanation of what is eBPF, and there are better resources, so we'll not waste a lot of time explaining in detail and why we chose eBPF. And we have a demo application that we are gonna use to demonstrate how eBPF can instantly start looking at the API traffic, and then we'll show how Levo, after taking the traffic, how Levo is able to create a very comprehensive inventory of applications, inventory of APIs, and even build documentation, especially open API specs for these APIs that enterprises can leverage. And then finally, we'll dig into some of the very interesting um, configuration options that we added for our Levo eBPF sensor to really make it scalable and to use it in an enterprise scale and enterprise environments. So with great power comes great responsibility, and we need lots of these configuration options. So it would be interesting to look at what all is available. So what's eBPF? eBPF stands for Extended Berkeley Packet Filtering. The BPF itself has been around for a long time, but eBPF has gotten very popular in the recent years. Um, and like I said, like eBPF has been used for observability, networking, and tracing and security use cases in Linux world. It's a Linux kernel technology. It's basically letting the user to dynamically program the kernel to get all these use cases. So there's lots of details and a nice documentary as well that was released recently. Go check out eBPF.io for all these resources. And we at Levo use. Why did we use Levo? Sorry, at Levo, why did we use eBPF for API inventory or discovery? So just a little context. At Levo, we solve API visibility and API security testing. That's our platform. In order to security test all the APIs, you first need to know what they are and what is their signatures, what does the documentation look like, and all. And when we started solving this problem, we were very particular about solving it in a scalable and easy way for enterprises. So that's why we chose eBPF. It allows us to seamlessly instrument and capture API traffic across hundreds of applications or even thousands without making any code or config changes in enterprises or in a company. One command, it immediately in real time starts capturing the traffic. It's completely framework agnostic, language agnostic. And the best part, we even give visibility into SSL traffic without asking for certificates or anything. And the capabilities of eBPF is what made us jump on this. We were the first to start using this for API use cases or API security use cases, and we are super happy that we actually made that bet because it has actually shown the returns throughout this journey. It's an involved technology, and getting it right is not an easy feat, but it has very high rewards when you do it right. So seamless installation with one command and roll out in minutes and hours across the entire enterprise, not in quarters. And framework agnostic, language agnostic, and visibility into SSL. Those were the main big reasons why we actually chose eBPF. So without further ado, one very important point: as long as it's Linux, we can actually install a BPF sensor and get visibility irrespective of the distro that you are using, like whatever Linux distribution that you are using. And it can also be running in like a container, non-containers environment, on bare metal, or within VMs, wherever you want, as long as there is Linux kernel, without caring about the distro. So these are all the reasons why we chose. Like I said, go to eBPF.io to get more details about eBPF itself. If you want to learn more, I would definitely recommend you to check it out. Several interesting use cases, not just API, but cloud security and other tracing use cases. Without further ado, let's get into the demo. Akshat?
Cool. Thanks, Buchi. So today we're going to be looking at a demo application called Crappy, which stands for Completely Ridiculous API. It's an open source project by OWASP. You can check it out. It's the code is available on GitHub. And we've actually forked it and added some new vulnerabilities as well as some small features to demonstrate Levo's capabilities better. So Crappy is, I mean, it's an application with multiple microservices. So it has 5 services. Uh, Community, which is a service in Golang. It has identity, which is written in Java. It has web, which is a Node.js frontend, as well as Node and React, as well as workshop, which is written in Python, I believe. And what we're going to do today is install the sensor alongside a running Crappy instance, generate some load against Crappy, and see the endpoints in the Levo dashboard. So let me show you the Crappy instance that we have hosted here. So all of them are in the prod demo namespace.
Akshat, do you mind increasing the font size slightly bigger?
Yeah, sure. Yeah.
This is better.
So this is Crappy. As I mentioned, it has 4 services, as well as, Mailog is a service which it uses to receive emails. It's a dummy email server and some databases. So this is our demo application right here. We've exposed it at crappy-prod.levo.ai. We'll come to that later. And before we install the sensor, let me also talk about the satellite. So the satellite is, I can show you that as well. We're not going to go into a lot of detail about the satellite, but yeah, I'll just give you a quick overview. So first of all, the satellite is, it receives the traces to instrument services and get data about API traffic data, and it sends those to the satellite. The satellite has a couple of services. We don't need to go into details about that, but one of the cool things about this satellite is the collector. So we leverage an open source project called Open Telemetry Collector, which receives the traces from the eBPF sensor in the open telemetry format, which is pretty popular these days. And then we have a couple of processors and exporters that we've written at Levo, which use that pipeline and send the traces onto our downstream services. But yeah, if you want, you can also use your own collector or your own service with the open telemetry format. With the eBPF sensor. So that's the satellite, and I've already got a sensor running here, but let me uninstall that. Okay, there we go. And the next thing I'm going to do is install the eBPF sensor. So uh, if you're installing for the first time, what you would do is you would usually uh, add a Helm repository like this. I already have it added, and you would update the repository. And once you update your repository, you can simply install the eBPF sensor. So I've already prepared a values file for this sensor installation. Maybe I can show you that very quickly. So uh, all of the data that is captured by this eBPF sensor is going to go to an environment called demo live in the Levo dashboard. So depending on the environment that you install the sensor in, let's say if you're installing it in staging versus production or any other environment you want, you can just add a string here, and that will show up as a service in that environment in the Levo dashboard. We also have, yeah, we have a couple of other things, but the main thing that matters here is the environment as well as the filter. So we're going to go into more details about the filter later. But what we're doing here is we are only interested in the traffic in the prod demo namespace. So that's what we're doing here. Let's go ahead and install the sensor now. It shouldn't take more than a few minutes. There we go. It's already done. Let's. Cool. It's already running. And just to check that it's up successfully, let's grab it. Cool. The connection with the collector was successful. So we know that the sensor is up and running fine, and it's connected with the collector and sending all data to it. Now the next thing we're going to do is generate some load on the crappy instance that we have. So I already have locust running here, and let me go to the locust dashboard and start load generation. So this is going to make a few calls to a few selected endpoints of crappy, and what we're expecting is the eBPF sensor is going to, it's already instrumenting the application in this namespace, and it should capture this API traffic and send that to the collector, which will process it and send it to the Levo dashboard. Cool. So I'll leave the load generation running here, and maybe we can. I'll hand it over back to Gucci, who can show you the APIs in the Levo dashboard.
Cool. Okay. So for the purpose of this demo, we'll be focusing more on the API inventory and API documentation features of Levo. There are a few other Levo does a bit more, and especially continuous security testing. But we'll be just focusing on inventory and documentation. So first thing, like Akshad was highlighting, the demo live is the environment that we are looking at. If you have several environments in which you install Levo, all of them will come up here. So we are looking at demo live environment, and as you can see, when I refreshed, the number of applications have gone up by one, because after Akshat has installed the sensors, in real time we are starting to receive application and API information. And first, in the insights, we actually give a very high level overview of this. As you can see, in real time, we are not only looking at applications, not only discovering them, but we are based on some heuristics. We are even categorizing which ones are external versus internal. If they are internet facing, these are external applications. We even detect the third party applications where you are calling to somebody else, and the same for APIs as well at the API level. And if you also notice these columns like PII, personally identifiable information, so in real time we inspect the data through all these APIs and classify the APIs as different data types, and you'll be getting all this information in real time. So let's and you also see an aggregated summary of what all sensitive data is exposed from your environment applications and all the APIs that you are using. So there are different sensitive data types that we detect automatically, and you can also add your own custom data types instantly as well. So with that, let's jump and look at the inventory. As you can see, these are the four different services that Akshat has pointed earlier in the demo, and all four of them have come up instantly in real time. Crappy Web Identity Community Workshop, and if you see, they were just updated or created, and there's also information about the overall endpoint count that you can see, and how many endpoints are having PII or sensitive data. Even the authentication is inferred in real time, like how many of them are authenticated versus not. Uh, all the details are coming in real time, and we can also look at all the individual endpoints. So this is the endpoint inventory within each and every application. As you can see at the endpoint level, again, the information about authentication as well as PII and all of that is inferred. Let's go to this dashboard endpoint. So we are digging into one endpoint. This is probably one of the most information packed and useful screens where you are actually diving deeper into one particular API endpoint or operation. This is a get endpoint, so the request is empty, but you can actually look at the response. It has the full response schema with annotations overlaid with the PII annotations. You can actually see them much better here with the exact the response in 200. Whenever the response status code is 200, in the body there is a field called social security number, which we identified as a social security number. Here we the detection is working not just based on the fields. We are actually looking at the data and applying some regex matches and some basic machine learning classification algorithms as well to classify this. So even if you were to name this field something else, it would still be detected as a social security number. um, and and we do that again in real time across all of the APIs. And here if you see, authentication details are inferred. And something very interesting, we are also inferring the authorization or any roles that might be used at the application level. Like if you are using OAuth scopes or if you are using RBAC. So we can, in the interest of time, I would not get deeper into the details, but these details are super important when you want to understand the full business logic and the context of the APIs. And the same we will leverage in security testing. But just having visibility into these level at an API endpoint level and overall application level to understand which users with what permissions are able to access this particular endpoint is super super helpful. um, and the change log tab, it's basically release notes or API change logs automated for you at scale. You can proactively get notified about every structural API change that gets added, because the idea is we are constantly looking at the traffic. So we'll be able to identify any structural changes that happen in the API schema, and you get notified. Our customers get notified in Slack or over email, and some of them are even piping these into Splunk. So this is super useful. Complete the API release notes automated for you at scale. And the traces is where you can actually see the full details of the API calls. And this is what was actually originally captured by the eBPF sensor, right? Based on which we build the entire application and API inventory. So there is request details, there's response details, and there is full context of the API call where it was captured. As you can see, there is context of the actual Kubernetes pod and container where it was captured. There is host details, and there is even the
Hey, Buchi,
command.
sorry. Do you mind zooming in a little?
Okay, thank you. Yeah.
Yeah, no problem.
Um, so yeah, this is where this is super important. Going back, we in our eBPF sensor, apart from just leveraging the eBPF logic to capture the traffic, we actually do something called metadata resolution. We are able to tell each and every API call which process or container it belongs to, and then we are getting the full metadata of that container, especially if it is in Kubernetes environment. We can do the same for Docker or other containerized environments as well. That helps in the security or observability world. Context is the king. Context is very important, and if you don't have this context, it will be hard to go back and give it to the corresponding team and understand it in a bigger picture. So to get that bigger picture, we get the full context, which helps us in our case. We are able to actually tell which team owns this service, or define that ownership, and give those additional details. And another interesting thing, as Akshata shown, there is a collector and the satellite components. Getting these traces into our platform is completely optional, and you have to explicitly opt for it. It's an opt-in. Otherwise, by default, we don't get any of these details. While we still unlock the rest of the features, the traces themselves and the actual data will be completely dropped on the floor in your environment. And there is another setting where we will be automatically masking all the authentication credentials and all of those as well. So there is a lot of flexibility on how your data is handled and where it travels. With that, so this is all on the inventory and visibility side. Let's jump a little bit into the documentation side. And we have already looked at the schema, but we build open API specs for every API, every REST API in real time. So as you can see, let me increase the font size. So this is a complete accurate OpenAPI 3.0 specification, and all the parameters will be documented here. And if you notice, we are even appending all the sensitive data or PII details as OpenAPI extensions as well. And we'll be appending the data type and all of that, and several more details. If you want any of those additional details, we can actually add them here as well. You can download it, you can use it with a very rich OpenAPI ecosystem is also pretty rich, and there is like several other tools like you can run mock services, you can generate some other test cases, you can feed it into other documentation portals. There's a very rich ecosystem there, and because this is fully compliant OpenAPI spec, you can use it with the ecosystem. As you can see, we even document the security scheme, so the authentication details and all of that will be fully transferable with the documentation. So yeah, that at a very high level, that's inventory, discovery, and documentation. Just to sum it up, we have demonstrated how easy it was to install the eBPF sensor in your environment with one helm install command that Akshat has demonstrated. And in Levo dashboard, you will be starting to see those applications, all of those applications, and individual endpoints at each and every application level. And at every endpoint level, you will be able to see the traces and the authentication and all these details, and the change log as well. Okay, I think that is the scope of at least demo. So now let's go to the, so we have looked at the demo application. We have looked at installing, and we finished the demo dashboard. Akshat, you wanna dive
Yeah,
into the sensor configuration?
sure. Yeah, I can go over it very quickly. Let me hide my screen to the stage. Okay. So the sensor supports a lot of ways to filter the traffic that it sees in your environment. So you can filter traffic based on PIDs, process IDs, or the command names that your processes have. You can filter traffic using IP and port. Uh, we also have very powerful Kubernetes filters, so you can, as we saw as we just did with in the demo, you can you can tell the sensor to only look at a particular set of namespaces, or you can tell it to ignore a set of namespaces. You can tell it to look at only one deployment, and yeah, so that's we have powerful Kubernetes filters as well as URL filters. So you can find a lot of examples for these filters in our documentation. We can add these links with the presentation. Uh, and uh, and we uh, the sensor also supports sampling
Yeah,
of the traffic. So
Akshat,
yeah,
if I may add one
sorry.
note, basically the filtering,
Yeah.
why is it important? We have seen several environments where, like, some of the customers, they choose very large machines and running literally couple of hundreds of pods on that as well. And also there are like different workloads running in on your machines. Like there could be monitoring workloads, logging related, and several other things. Not every API is important. Not every application is equally important to our customers. And when you're running at that scale, first of all, looking at all the traffic, um, and processing all of it is going to be very costly as well. And sometimes there could be some applications, sensitive applications, that you don't want to look at all. So we do it in
Hmm.
three. We apply three-phase approach. The first one is we actually ignore all the non-HTTP or non-API workloads by default automatically. We ignore all the database traffic and all of that. And then second step is we allow customers to filter, and that's where what Akshat just described is super important. Where customers can tell, hey, I don't care about the Prometheus related API traffic. Just ignore that, or I'm using Datadog as a monitoring tool, so just ignore all the traffic. That's why it's super important. And the third one is what Akshat is about to describe: the sampling.
So sampling allows you to only, as Buchi said, uh, a lot of traffic means may mean a lot like huge costs, huge egress costs, and all of those things like that. But sampling, so we have sampling at various layers in the sensor. So the sensor can sample traffic at the socket level, which happens in the eBPF code, and it can also sample traffic based on the URL of the endpoint path. And this is even configurable. So you can, let's say you only want 100 requests to be exported per second from the sensor. So we have a setting for that. Or you want, let's say, only two requests per endpoint to be exported from the sensor. So we have a setting for that as well. And we also have advanced settings when you want to sample the traffic at the socket level. So uh, yeah, I mean, uh, I think that's all. That's all about sampling and filtering. Would you please feel free to add anything?
Yeah, no, I think you covered pretty much. Basically, I'll just repeat the summary, right? Essentially, eBPF sitting on the machine, being able to look at all the system calls and all the HTTP, all the traffic, could be like drinking from fire hose. And to operate at that scale, you need lots of levers. So first level lever is actually ignoring all the traffic that is not necessarily APIs. At least as of today, we don't look at database and some other binary protocols and some of those. Like we only look at the HTTP. And then second level, we are able to have this very advanced filtering based on Kubernetes or non-Kubernetes, even on regular outside Kubernetes environments as well, based on host, port, IP, no, and several other, even based on URLs. So there is very advanced filtering capability. And third level is where sampling, like, okay, even if you're capturing all this traffic, like, do you really want to first of all, there's something very advanced that we do. Like if there are an application is pooling connections, and there could be 100 HTTP connections or 100 TCP connections. Do you really want to get from all of them, or like do you actually want to only capture traffic from one or two? Uh, so that's at the socket level sampling, and similarly at different layers we sample, and the final last sampling is at the exporting level as well. So combining all this is where we were able to build this very advanced sensor that's highly, eBPF itself is highly programmable, but on top of that we actually made our sensor itself highly programmable and configurable to lend itself to work at enterprise scale without worrying about the cost, scale, impact to your applications, and the adoption time. So our goal is to basically make it like literally in minutes, or in less than an hour, an enterprise to take it and adopt it and start seeing the benefits like in real time. And we are super happy that we chose that design. We are super happy that we bet on eBPF, and we are super impressed with the results, and happy that we are able to deliver this to customers. So with that, I think the last one in the demo, let's look at other ways to install the sensor as well. um, Akshata has demonstrated how to install it in Kubernetes with Helm package. But Kubernetes is not the only environment where you can install, because eBPF is Linux technology. Wherever you have Linux, you can install there. You can install it in Amazon AWS ECS as well. We have a Terraform template or script for that. And this sensor runs as a Docker container. So wherever you have Docker available, you can run it as a simple Docker container with just one Docker run command. And we have a apt package as well. So if you have distros that support apt package, you can install with apt package and manage it with systemd there. And we have RPM and yum as well for the distros that actually support this. So basically, as long as you have Linux, it doesn't matter which cloud you are in, which whether even if you are on completely on premises. And we support most of the kernel version. So you have Linux, you can take our eBPF sensor and get visibility and API documentation instantly. And then the best part seems like Microsoft has been betting on eBPF support for Windows as well. So we have been watching that progress. It's making a lot of it has come a long way. I think it's alpha or beta ready the last time I have seen it. I think we are not far from actually having our eBPF sensor running in the Windows world as well, and we are super excited about that. With that, hopefully that's been helpful. Hopefully you've seen how quickly you can get started. Please feel free to sign up. We have a freemium, and we give the product for free for up to 100 API endpoints. We don't cap based on how many sensors you install. So you can actually give a try without even putting your credit card. And please ask questions. Don't be shy, and keep them coming. For anything specific to eBPF, like we will answer everything that we have gone through, and we are happy to share the learnings that we had in this journey as well. But feel all right. Okay. First of all, apologies. I got a message saying resolution was not great on some of the UI screens. I think we have zoomed in some areas in some screens, but there's some areas of the product we forgot to zoom in. Sorry about that. We will definitely do a better job in the future demos. um so yeah, hopefully you enjoyed the talk, and are able to see the power of eBPF. Now let's start taking the questions. The first question is, eBPF sensor that Levo uses proprietary, open source, or forked and rewritten? It's completely written by us from scratch. It's proprietary. We didn't fork it from anywhere. We didn't rewrite it. When we were getting started, we looked around, and there were some sample projects which were trying to do something similar to this. In Python, we have seen some projects. A lot of those were written for ad hoc querying purposes. It's like, I just run it, maybe get data from one program just for one or two few seconds or 1 or 2 minutes, not more than that. But here, like I said earlier in the demo, our product is designed for scale, and customers are like, this is designed to run in production. So we said, like, from beginning, from ground up, we were very sure about how it's going to be used, and how the scale is going to be super important. So we focused on getting all of those basics right, the scalable design, the configurability, and all of that. And we have written it in C++, so that we can squeeze out every ounce of performance. Just to give you an idea, like, some of our customers have discovered thousands of APIs, like I think 20,000 plus we have seen in some environments. And the largest machine that we have seen, there were 220 plus pods running on the same machine, and our sensor was able to run without sweating. I don't think by picking some of these Python based sensors or code that was already out there when we were getting started, I don't think that could have given us this kind of scale with the CPU and memory resource usages that we are able to run it with. So it's completely proprietary and written from scratch in C++ by us. I'm pretty sure somebody must be thinking, why not Rust? But let's wait. Let's wait to see the question coming from them. Good question. Any more questions? Okay, I have to make sure I'm seeing it all the questions right. Don't be shy. I was expecting tons of questions. Okay, no more questions. That's super clear. Hopefully, that everybody followed. Um, okay. Next question. How do you filter API traffic from the rest? Is it configurable? Great question. I think so right now we are doing it purely based on the ports. At the lowest level where you're tapping into this traffic, like, until you read some bytes, you would not be even be able to tell whether it is APIs or not, or whether it is database or application, REST APIs traffic, or all of that. So what we have done is we have chosen bunch of well-known ports on which a lot of well-known databases and all of this communicate, and we ignore those ports by default. And is it configurable? Yes, it is absolutely configurable. So, and you can go ahead and exclude some traffic. Like, for example, we have seen Cassandra database, for example, that uses REST APIs. So we just excluded those ports, and we are able to even see Cassandra's traffic as well, because again, at the lowest level, we don't differentiate this. So it's in the form of ports, and it's highly configurable. At some point, I think this sensor can be extended to start looking at some of these binary protocols as well. Um, Actually, gRPC is a great example. Like, we in the first version, we were only looking at the HTTP 1.1, and at some point, our customers were using HTTP 2, so we went ahead and added HTTP 2 protocol support. And after we had HTTP 2, it was super easy to add gRPC as well. So we went ahead and gRPC. I think we have heard from a couple of customers that they have some proprietary RPC protocols as well. The design is in such a way that once we capture the traffic, we have protocol decoders for these buffers. And the latest one we heard from customers is they want to decode the fixed protocol, financial information exchange. And all we need is just go ahead and add one more protocol decoder. So we added that very simply. Like, I mean, the gRPC was super easy. Like, we added gRPC API discovery support to our product just within few days. And we can now go ahead and add for any new protocol or any database and all of that very easily as well. So it's all based on the ports at the lowest levels. Cool. 9:40. So okay, we'll take probably another question if anyone has. And feel free to drop the questions or DM me if you have any other questions, or if you don't feel like asking here. Uh, there are like several lessons, especially if any of you are planning to roll up the sleeves and maybe even try out. We can tell where you will have the biggest problems. Verifier errors is okay. What is verifier error? Like, because not many questions coming, we can probably talk about that. Very very important, especially if any of you are actually planning to tinker with this technology. So these eBPF programs are nothing but programs that we are loading dynamically into the kernel, right? But obviously you cannot load any random programs. Kernel should not allow you to do that. There are very strict standards and rules around that, and that's the component which actually verifying these programs is called verifier. And some of the trickiest and hardest problems to debug we actually had in that verifier area, and team has done like has to spend a lot of time and dig into the details and really work hard to get to the bottom of and resolving some of these things. There's lots of fun stuff in, I mean, like we have experts even a lot more experience than me with eBPF on the team, and they probably can give a lot better stories actually. But verifier errors is one common thing. But I think for simple programs, it probably you may not hit it. But at scale, and especially when you're trying OpenSSL, for example, we instrumented OpenSSL to get seamless visibility into SSL protocol, and that was one time where we were running into a lot of these verifier errors. Cool. Just wait for another minute to take the last question. Otherwise, feel free to ping me. I'm on LinkedIn, DM me, or on Twitter as well. You can reach me anytime, or you can reach me at bucci@liver.ai if you have any other additional questions. All right. Thank you, everyone. Really appreciate you joining the call, and hopefully the demo was helpful. Uh, Please let us know if there is any particular areas or topics that you would like to see the demos of future. uh, we will definitely do based on the asks or user demands. Thank you all. Have a good day and good night.